Hey everybody, today I will do another video and we will continue on the same topic, multi-variable calculus, and today we will be doing something similar as we did last time. We will be determining the collinear points using vectors, right? So, so the topic is using vectors to determine collinear collinear points, right? In other words, that is the topic, right? That is what we'll be talking about. In other words, it's a concept that we'll be using, right, to solve problems, right? We're using vectors to determine collinear points. Now, in this example, we have 2 points, and then we have another third point, and we have 3 different points altogether, right? But we will see how they correspond to each other in the Cartesian plane, right? So, okay, so we have a point, right? We have 3 points. We have 3 points, P, Q, and R. And point P, Q, and R are basically in a 3-dimensional space, right? P, Q, and R. Now, to do that, we need to obviously write the points, right? So this is just what we're doing, right? So let me just save some space here. So here I will say that point P is, I don't know if you can read this P, but it's kind of P is 1 comma -2 comma 3, right? And then point Q, that is point P, point Q, point Q, point Q, 2 comma 1 comma 0. And R is, okay, so let me just do it at the box space. N point R is 4 comma 7 comma -6. 4 comma 7, comma, negative 6. Right? So, right? So we understand this. We're dealing with a three-dimensional space, right? So we're dealing with what? We're dealing with X, Y, Z. We're dealing with three variables, right? So here, basically what we're doing is we will find the difference between those points, right? We will write these vectors like this. So we will try to find the difference between point Q and P and Q, and also R and P or R and Q, right? We will pick a point, right? Usually what they do is just pick P, right? So let's first our job is to find the difference in the vectors, right? In other words, the magnitude, right? Now, I will say not the magnitude. It's I will say that it's just the difference in distance between the vector, to be more specific, right? Because I am doing basically final distance of a point minus initial distance of that point, right? So in this case, if I want to find the point between Q and R and P and Q, I'm sorry, between P and Q, then obviously Q is my final point. P is my initial point, right? So I have to find the difference between this and this, right? Between this and this, which this is going to be my final, this is going to be my initial, right? Then here, obviously, this is going to be my final point, this is going to be my initial point, right? Because usually they use P, right? Now, so to find the vector, right? To find the vector between the component in a component form, right? So basically what we're using, right? We're using the technique of component, right? To find, okay, so we're trying to find a component of this between these two vectors, right? That's why that's our first goal in this case, right? So how we write a stop in component form, right? The difference, right? We usually take the difference of the vector, right? So how we do that? Well, again, final minus initial. How do you just initial velocity, for example, right? You have initial velocity. How you find the initial velocity? How you find the difference between initial velocity and final velocity? You start doing 10 miles an hour, right? And at the end, when you got to your destination, because your car cannot take off, right, at 45 miles per hour, the car has to slowly pick up the speed. Okay, so you start at 10 miles per hour. Your speed increases according to time, right? You will take some time to get to 45 miles per hour. So how you find the difference? Well, final minus initial, right? Final minus initial. Oh, final distance minus initial distance, right? Okay, so Same thing here. We're dealing with three-dimensional space, right? Now, okay, so how do I find the difference between this and this? So, okay, so we write it like this. We put, and this is not incorporating again. I have to use another one probably. So, P, and then Q, and we put an arrow on top. That arrow means that it's a vector. It's going to be a component vector, right? Between those 2 points, right? Now, what is my final? My final is Q. So it'll be Q minus P, correct? So how do I do that? Well, the following. I write something like this, right? I put my X value, X final, right? Minus X initial. So 2, what? Minus 1. What is my initial value on P? It's 1. 2 minus 1. Put a comma, right? Then, what is my next point? My next point, obviously, is 1, right? But what value corresponds to? It corresponds to Y. Y, right? So Y final minus Y initial. So I get 1 minus, be careful, here you got a negative 2. Put the negative sign outside because I am subtracting another negative. I am subtracting a negative 2, right? So making sure you do it like that. So now, what is my Y? Y is 0, right? So put a comma on there, and I said, I'm sorry, C is 0 here, right? This value, now I'm doing this value. See? Now I'm doing Z, right? So component, right? This component right here is going to be 0 minus 3. Okay? Now just do the math, right? So now I get P, right? PQ is equal to, that's a component vector. It's going to be equal to what? It's going to be equal to 1, right? 2 minus 1 is 1. Here I gotta be careful because I have to change the sign of this. Change the sign of that and change the sign of that. When I change the sign of this becomes what? Becomes a positive. So this becomes 1 plus 3. I'm sorry, 1 plus 2. So 1 plus 2 which is equal to 3. I got my 3. Put a comma on it. That is the new component vector for the value of Y. Right? Now, next I do what? 0 minus 3. So 0 minus 3 is simply minus 3. So minus 3. And that will be the point. Right? Now, this will be the point. This will be the point where that vector in component form is laying in the Cartesian plane in the three-dimensional space. Right? Now, let's do P. We did PQ, now let's do PR, right? PR. We're using this point, right? Same thing. Let's see. Maybe get a different marker that is working. Okay, so now I am doing PR, right? So, okay, So what is R? R is for, I am doing my X value now, my X, right? Minus what? Minus, what is P? Well, I'm doing P, right? So hopefully you can see this. This is a P. All right? Now, what is my next value? It's minus final minus initial. Again, it's 1, comma. Second, I got 7, right? Minus a minus 2, right? So I got 7 minus, again, a minus 2, right? Put a comma on it. Now, I got negative 6. Negative 6 minus what? Minus 3. So I got negative 6, right? Minus a 3, minus a 3. Close those parentheses. Do the math. I got PR, right? Component vector PR is equal to the following. 4 minus 1 is 3, comma. 7 minus a minus, minus and negative to change the signs. Do the math. Change the sign to the math. Okay, so this becomes a plus now, right? So that becomes a 9. 2 plus 7 is 9. Put a comma on it, right? Next, 6 minus 3. Why is it minus 3? Well, it was positive, so all I have to do right now is put a minus 3 right there, right? So now, minus 6 plus negative 6 added to, right? Added to that, to the negative 6, adding what? Adding another piece that is a negative, which means that I am combining two negatives, right? Which is equal to what? Equal to 9. So this is equal to negative 9, right? Because I am adding two negatives, right? So I am adding negative 6 minus 3, right? So I am adding two negative numbers. Now, this is my PR component. All right, now, and that is exactly correct. Now, let me do a little graph here. Hopefully, I can do it. This is not easy, but I will try. So here, this is how I will try to do it. So we have those 2 points, right? So we have something like this. So something like that. Right? Then we have something like that, right? We say that this is X. No, I'm sorry. No, this is Y. This is Y. Alright? And we say that this is X. Okay. Now, we do another line here, straight up. So, we do another line, straight up. And that is Z. That is a Z, right? So you got X, Y, and Z, right? And Z in three-dimensional is like you're looking at something like this, right? So you're looking at something like this. X, Y, and Z, right? So you have three planes, three different planes, right? So the X is popping directly to you. This is Y, and this is Z, right? So when you're looking at the three-dimensional, you're looking at something, and that's why I cannot do it. Obviously, I cannot do it like that because the board doesn't let me. Doesn't let me. It does not let me, right? If I get a laser beam and I point it right to the board, I will want to see something like that, right? Yeah, but then that will not really help. So that's why I do it like this. And this is basically right. So this okay. So this is just see this continues like that. It's a dotted line because X continue in that direction, right? Now Y also continues in this direction, right? It's three-dimensional. Now I am doing just this for illustration purposes, right? So okay, so now I have this, which I don't know if this is kind of faded, but so this is how we will look in a three-dimensional, right? Now, let me try to point P, Q, right? I am going to the X coordinate. I'm going 1 unit on the X coordinate. And also making sure that it's positive, right? X coordinate is positive. So I go 1 unit on the X coordinate. Now, from the S coordinate, I go 3 units, right? So what I can do is just drop a line, right? So I am dropping a line between these points, right? So, well, let's see. Do I want to grab the different, or I want to plot the real just let's do the numbers. Let's just do the numbers. Let's not do just the numbers, the initial points, right? Okay. So I have it too, right? I have it too. So 2. 1, 2 on the X, correct? So, but then in the Y, I am going up. I am going up, negative, and this is my negative Y. Right? I am going how many units up? I am going up, negative 2 units. Actually, it's 1 unit. Okay, so 1 unit. I'm going up 1, 2. All right, so 1, 2. All right, and this is the point where the negative 2 y lays right here. This is a negative 2 on the point on the y, right? So this is a negative 2. I don't know if you can see, but it's right there. So let me see if I can actually get a marker that. So this is negative 2 on the y-axis, right? Y. Now, from that point, I will have to go up 3 units. 1, 2, 3. Right? And that point is going to be here. So basically, I will do something like this. I will do something like this. I will create a point here, right? So I'm going, okay, let me explain this again. I'm going negative, I'm going positive, positive, these markers are not really doing a good job for me today. All I can do is try. Okay. I don't know. Maybe like that. Okay. Okay. So what I can do here is the following. So I have this point, right? So I can actually drop a point. So I go 1. And actually, you know what? Because this is not the scale. This is, like I said, this is not easy. Not easy to do. This is not easy. Because, first of all, I don't like having 2 different colors on one in the graph. Okay. So this probably would be 1 right there. It's going to be closer, right? It's going to be closer to, if I can actually do here, make those points tighter here. That will be 1, that will be 2, and that will be point 1 right there, right? That will be 1 on the x-axis, right? Now this here will be 1, 2. So I go in 1 up on the x-axis, positive. I am going negative on the y-axis, right? From the y-axis, I am going 3 positive on the x-axis, right? So, and also this is not to scale. You can see that this is not to scale. This is very, like I say, it's not easy to do it just. Okay. So maybe if I can tiny, if I just do it, reduce the space in between them like that. 2, 3. Okay. So I'm going 2, 1, right? So I'm going to 1, and then I'm going 2, and from 2 I'm going 3 up, right? And this will be the point. I need to erase this just for now. So this will be the point, and from here, I can actually try to do a line, right? Try to create it's going to be right. So this is a 3. So this is, it's going up. About, actually, let me do it like that, right? And from here, I will create a line. This line is going to go straight crossing that. Doesn't look like a straight line. Again, this is not easy. It's not easy process. Not easy. Not easy at all. Because it's hard to do this to scale. Right? So maybe. Okay, so then I do 1 and 2. Okay? And then 3 is going to be up here, and the c-axis is going to be about there. Going to lie somewhere. Because we're dealing with 3-dimensional though. It's not easy to just maybe I can move this. That would be 1. That would be 2. Right? Right? So, and then 3 is going to be on the c-axis, is going to be around here. And from here, I'm going to graph it all straight down. Right? So that will be my point here. Right? So that will be my point. Point P. Right? This will be point P. Right? This point right here. Right? And P, the value is what? 1, negative 2, positive 3. 1, comma, negative 2, negative 2, and 3. Right? Okay, that will be the first point. Now I will be dealing with the rest. So what is the rest here, right? Now I have another point, right? What is the next point that I have? Well, I have a 2 on the x-axis, right? And remember, 2 and the x-axis is about here. About there, right? 2 and the x-axis is about there. Now, that also lies into approximately the same line, right? So here is, because we're dealing with the 3-dimensional, I mean, it's not easy to make these graphs at all, right? So at this point is 1, right? At this point right here, point Q, the point Q, the Z is 0, right? Which lies about two, 1, 0, right? 2, 1, 0. So where is y in this case? Well, y is here, but y is 1. So y is 1. So y is actually here, and the x value, technically, see, I did not do this scale again. I mean, this should be closer, the distance here should be closer to the origin. The bottom line, that this point right here, at y equals 0, I'm sorry, at z equals 0, is going to lay right. Point Q is going to be about this is not to scale. All right, this is not to scale. So here the x-axis should be closer. So this here, right? So then this will be, okay? So now this line right? So at this point right here, it was this, right? So I understand this a little high. Make a point right there. That is the point, right? Point P. Point Q is going to lay right there at that point. So this is going to be point Q, right? So point Q, right? So C is here, and this is the tricky part because C is laying right there, right? 0, right? Because Z, this is X, this is X and Y. C is right here. But if C is 0, then Z can be here, it can be here still 0. C does not increase in X and Y. So C is here 0. And if it's a Y here, but if it's in this line, it's also is 0. So here is Q. So that will be Q. The value Q, well, is 2, 1, 0. 2, 1, and 2, 1, 0, right? Now, okay, so what, okay, so now, how can I determine if that is the correct point? Well, if I go to this thing here, so this is, see, this was, actually, let me go make this closer. And this is, right? So if I start at X, if I start at X, right? X is equal to 2, right? Let me just clarify this. X is equal to 2. I go to Y. Y is equal to what? 1. So, but where is Y? Y, 1, positive is here. So from 2, I go to Y. And I wish I had more space to work with. I wish I had more space to work with. Okay, so from X, I go back, see, I go back to what? 1 unit to Y, right? 1 unit from X x2, I go back 1 unit to y, which lies me at that point, right? And that's why Q is right there. Now, but what happened? Why I went to y? Because y1 is here. See that? Y1 is here. So I go back, right? Where is z equals 0, right? Well, I go to y is equal to 1, right? Y equal 1. Here, y equal 1. Then, from y, I go to what? Z. Where is z? Z is at the origin. Z is 0. That's why this is point Q. I hope that makes sense. So point Q is Q, right? So Q is 2, 1, 0. Okay. Now, where is R? R is at x equals 4, right? So I start, this is 2, 3, 4, right? Okay, from x equals 4, and this is kind of not the best. You need to forgive me about this because this is not, the marker is not cooperating with me. Okay, now it's better, right? So I go 1, so 1, 2, 3, and 4, right? Now, starting from x. Starting from x again, right? I hope this is making sense. Starting from x, I'm going to travel y 7 units, right? So, let me just make this little more to scale because okay, so that would be y, right? So that would be 2, 3, 4, 5, 6, 7. I am traveling from x equals 4 to y equals 7, right? X equals 4. So x equals 4, right? To y equals 7, right? But remember, to y equals 7. Now, from y equals 7, I have to go how many units to z equals negative 6? I have to go down. And remember, this is the z, right? This is the z. So I gotta go 1, 2, 3, 4, 5, 6. Approximately here. That would be negative 6. Okay, so I go back, right? I go 7 units, 1. So from here I go 7 units, right? And then from there I drop it down. I drop it down, right? When I drop this, go from 7 to, I'm sorry, from 7 positive all the way down to 6. Right? And this will be my point right there. So if I connect that line, right? So that will be what? This point right here will be R. R is equal to what? 4, 7, negative 6. Now, this one right here, So this is, right? So this is the C, right? Negative Z right here. Negative Z. This is negative Y. This is a negative Y. Negative Y, and this is negative X. All right. So to graph this, the best way to do it will be kind of right from here, like a box, right? And then to here. And then from there, you go up, right? Then that will make the point, right? Actually, I could have gone up. Yeah, I could have gone up a little bit and then connect those. You have to make more. Okay. Okay, so what I can do here is the following, right? So whatever worked for you, remember, your teacher's not gonna asking you for perfect in this, perfection in this. Okay, so something like that, right? I'm going straight, 6 units, and then from there, actually, it's so, right? And then something like that. And then here, remember, this point right here, let's clean this up a little bit. This is not an easy process, but it can be done. All right, so remember that this is about a line going to the y-axis, So, like that. Right? There's a dotted line. I want to try just to do a dotted line to show. Like that, right? Now, from there, I gotta drop what? I gotta drop a line to here. Then all I have to do is kind of make it like that. Okay? So from here, remember, I am creating a plane, another plane, right? So the one second. Maybe if I truncate a little bit of this, right? So here, right? So this is a C, right? C going up, but at the same time, C continues down, right? So C will continue from that point down. See that? And that is how actually, again, because this is not the scale, this is not the scale. This, remember, the distance are not perfect here, and that's the problem. So here, the distance are not the same between one of these sticks to another. So here, it will have something like this. All right? So technically it's 7 will be here, right? But this will be 7. But at the same time, right? So like that. Right? So that will be, and then that will be C. Right? So I am creating another copy of the plane. That's what I'm doing. Another copy of the three-dimensional. So this is not easy, but it can be done. So right? So here, that's why I want to create a data line so I don't get confused. This is the line right here, right? So you guys don't get confused. So this is the data line. This is representing another copy, pretty much, of the C-axis at that point. Right? So now I drop another C-axis down. Just let me do a data line. Right? So, and that will be the point right there. Right? That will be the point of interest. Right here, which is R. Right? So R is going to lay here, which is what? Which is R is 4, comma, 7, comma, -6. Right? Okay. So this is the point. And right? So that will be the point, right? So this is the direction from 4, positive 4, to y, right? Equal to 7, right? And then I got, and then z, right? C continues up. I mean, C continues showing up here, but I mean, for some reason they don't show it, but C actually continue going up at the same time. I mean, up, right? Because it's just being moved to the direction, right? So yeah, so that will be the point, right? And the point at Q, which is, I had it here, point Q is right there, right? It's right here. This will be point Q, so Q is what? Simply 2, 1, 0, right? Why? Right? Because you go towards the y-axis, right? And how many units you go? Well, you do, but over here it will be just too tiny to try to do this because you don't have a lot of space. But so x equal 2, you go up, you go across what? You go across y 1 unit, and where it lands you? Well, you're going from 2, right? From 2 to y equal 1, which is actually get you to this point. From 2 to y equal 1 is equal to this point, right? But where this point laid? This point lady is laid right at c equals 0. So that's why you get a c equals 0 right there. So yeah. So that would be the video for today, right? And this is the mathematics. This is how you do it. The hardest part is graphing this. That is the most difficult part. Because here, especially when you don't have like something that guides you like a graph, like a graph paper, it's kind of difficult to do it, but again, it can be done, right? Okay, so that's it. Thank you for watching, and I see you in the next video.